Okay, let's get going. All right, 1.4. So for 1.4, it's what we've done before in a distance formula. We've measured segments. It's just applying it on the coordinate plane. So we need to find perimeter and area, and I'm going to sort of skip through a lot of this here to get to the important bits. Okay, so you need to know what area and perimeter is, and you need to write this in your notebook. So there won't be a note sheet with this, so make sure you have your notebook, and you will definitely need a calculator today. So get a calculator out. And first thing, area. Okay, we've used area a bunch, but just got to be clear, make sure we're all on the same page here. Area is a two-dimensional surface. And one thing you need to know about this is it's measured in square units. Okay, so make sure that you're doing inches squared, centimeters squared, miles squared, whatever it is, you're doing it in square units because it has two dimensions. So that's why the square is there, okay? Perimeter, that's the distance around a shape. So basically, just find all the lengths of the side and add them up. That's your perimeter. Okay, so you probably already know this, but we're going to do it in coordinate plane. So it kind of important to point this out because this will guide our steps. So first things first is for a rectangle. For rectangle, obviously perimeter you should add up the four sides, but for area, it's going to be base times height. Okay, and it's important for you to know that anytime you see B and H, H is for height, and B is for base. And one thing to know is that these two have to be perpendicular. They have to make it 90 degrees, and that'll be important in a second here, okay? All right, so for triangle, our area is 1/2 times the base times the height. Okay, so those are two equations we're going to use, and one thing you need to know is that these must be we call it perpendicular, but you can just think of it as 90 degrees from each other. So oftentimes you'll see triangles like this. Okay, so if this is my base, then this is my height. But it won't always be like that. Sometimes you'll have this as your base, and the height has to be perpendicular to the top of the triangle here. So you have a little height length that goes through the middle of the triangle, and that's because we need a 90 degree or a perpendicular height from the base, okay? And sometimes it'll even look like this, where we have our height is here, and our base is here. So it won't always be the bottom. They just have to make 90 degrees, a 90 degree angle when they meet. Okay, so it can look kind of different depending on how it's oriented, but base is not always on the bottom, just has to make a right angle. Okay, so here's what we're going to do. We're going to find if this will cooperate with me here. Go away, dotted lines. Okay, so we're going to find the perimeter of DEF and the area. So here's a good spot to pause the video. Make sure you have this triangle jotted down in your graph paper. If you don't have graph paper, just make a little XY axis in your notebook. We need these coordinates here. Okay, so jot that down, pause the video, and then resume. So we're going to start with the perimeter. Oh, ding dong. So the perimeter means we have to find all of these lengths, which means we're going to have to use distance formula. Now, anytime we have a line that, lines about the grid, or a segment, like this F to E here, that's really, really easy because we don't need distance from it, we can just count it. Okay, so we can find F to E right away. So that's one of our sides. That's this one right here. F to E. So we just got to count it. Looks like it's 1, 2, 3, 4, 5, 6, 7, 8. Oh, we got an announcement.
Would Parker Grant, Brett Lindbergh, Matthew Hirschberger, Lane Hirocco come to the office?
Great. All right, so that one's 8. We can just count that, but now we need to use distance formula. So if we say I'll just do it in green here. If we go from F to D, we're going to have to use distance formula. Okay, so if we're doing F to D, well, we got to do the square root of, and you can decide which one is your x2, y2, and which one is your x1, y1. I'm going to use this D as my my x2 and y2. So I'll do x2 minus x1. Actually, I'll just write it up here so we're on the same page here. So we got x2 minus x1 squared plus y2 minus y1 squared. Good. Should have that in your notes already, but it's up there. Okay, so x2 is going to be my 1 from D. And I'm going to subtract that from negative 4. Negative 4. That's all going to be squared. And then I'm going to add that to my y2, so it'll be 3 minus negative 3. And that's going to be squared. Now I always say, just think of it as how far apart are these? How far apart is 1 from negative 4? Well, it's going to be 5, and if we do keep change, it's really 1 plus 4. So we got square root of 5 squared, and then 3, so change to plus, because keep change, 3 plus 3. So it'll be 6. So it'll be 5 squared plus 6 squared. Well, we can do that. We'll need a calculator here in a second, so I'll run and grab one. But 5 squared is 25, and 6 squared is 36. So we got 25 plus 36 all under square root. We add those together, and we get, what do we get? 61, square root of 61. All right, so I want it as a decimal, okay? Obviously, we have 8 units up here. It's hard to tell what exactly 61 units, so get a calculator. Just take the square root of that. So we had square root of 61, and I want 3 decimal places, so this will be 7.810 units. Okay, so almost 8, just under 8. So let's do this last one here. I'll do this in blue, and we've got from here to here. So we're going from D to E. So D to E. And I'm going to treat these points, 4, negative 3, as my second. So this will be my x2, y2. So I'm going to do 4. Set my calculator down. I'm going to do 4 minus 1 squared. Actually, why don't you pause the video here and try to do this one on your own. You should be able to do distance formula at this point. Plus negative 3 minus 3. Hello. All right, 4 minus 1 is 3. 3 minus negative 3 is negative 6. So it should be the square root of 3 squared plus negative 6 squared. Remember, when you square a negative, you're going to get a positive. So we end up with 9 and 36. So 9 plus 36. And 9 plus 36 is 45. So we need the square root of 45. Which is, if I grab my calculator, square root of 45, and I get 6.708. Okay, so now I have all 3 of them. I need to add them all together to get my perimeter. So I'm going to do 6.708 plus 7.810 plus 8, and that should give me my answer. So I'm going to add those up. Plus 7.810 plus 8, and I get my perimeter equals 22.518 units. Okay. Let me just look this over, make sure I didn't make a mistake here. 5, 6. 3 and 6. Okay, looks good. All right, so now what we're going to do is we're going to find the area. Okay, so we found the perimeter. Excellent. I just want to tack this on. I want to find the area of this triangle here. Okay, because it's a little tough to see when we have it in the coordinate plane. But remember, we need a base and a height, And it's 1/2 base times height. So I'm going to scroll down a little bit here. And this one's actually not bad once you have it graphed. Because remember, area equals 1/2 times the base times the height. Okay. Remember, the base and height have to be perpendicular, and it's always going to help us out a ton if we can make the base line up with the grid lines. Okay, there's only one side here that lines up with that, and that's this F to E right here. So I'm going to call this the base of my triangle, and that means that the height has to be perpendicular. It has to make 90 degrees and go straight up from the base. Now, we want it to measure the actual height of the triangle, so we want it to reach this point up here at the top of the triangle. So all I'm going to do is I'm going to draw a line down from the highest point of the triangle to the base, and now I have a right angle, and this is going to be my height. All right, we can just count these up. We already know that the base across here is going to be 8, and we can see that our height is 6. So our base is 8, our height is 6. We can just plug this in, 1/2 times 8 times 6. 1/2 times 8 is 4. 4 times 6 is 24 units. Now be careful, it's not just units. If we're talking about area, we're talking about a 2-dimensional area. So we have to say units squared. Okay, so perimeter, a little bit more work because you have to use distance formula. And then for, area, typically it's a lot quicker because you're just looking at lines that go along the grid. So you can just count them. Okay? All right, so let's look at one more example. And let's look at this one. All right. So we're going to do perimeter and area. But pause the video here, graph it, and then try this one on your own. And I'll do this on the board once you've given it a go. All right, so first we want to graph it. So -3, 2. And just so you know, on your assignment, they may not require you to graph it. I strongly recommend it. It makes it a lot easier, and you won't make as many mistakes. All right, 2, 2, and then -1, -3. So we got G, H, J. Okay, perimeter, we want to find the distance. Easiest one to find is G to H. G to H, we can just count it. Looks like it's 5. We can just pick one now. Let's go from G to J. And we got to do distance formula because it is a diagonal. We can't just count it. So we want to find the distance from G to J. So I'm going to do my x2, which would be 2 minus -3. And I'm going to square that using these. Oh, I'm sorry. I should probably look at what I'm doing here. Let me delete that. I just said I'm doing G to J, and I was doing H. Okay, I'm going to do G to J first. So I'm going -1 and -3, my x2 and x1. So I'm going -1 minus -3 squared. And then I'll do y2, so -3 minus 2 squared. Okay. -1 minus -3, it's really +3, so I end up with 2. So it's going to be 2 squared, -3 minus 2 is -5. So we end up with -5 squared. And if we put that all in there, we get 4 and 25, so we get square root of 29. And the square root of 29 is square root of 29. 5.385 units. Okay, so there we go. We got 2 lengths, we got 1 more length to go. And the one I'm leaving out, we got GH, we got GJ, we got to do JH. Or we'll say HJ. All right, so now, I'll do this one in a different color. Now we're doing H to J, so this will be my first point and my second point. So my x2 is -1. So -1 minus 2 squared. It's all in blue here. And then my y's, plus negative 3 minus 2 squared. And yeah, so let's do this. So negative 1 minus 2 is negative 3. So we got negative 3 squared. And then negative 3 minus 2 is negative 5. So it'd be plus negative 5 squared. Let me just make sure I didn't make a mistake here. Negative 3, negative 5, good. And I'm going to scroll down. Doo-doo-doo. All right, so now 3 squared, or negative 3 squared is 9, negative 5 squared is 25. So we end up with the square root of 34. Square root of 34 equals 5.83, and around that to a 1. 5.831. All right, got to put it all together. So I got to add these 3 together. So I got 5.831, 5.831 plus 5.385 plus 5. And I get 16. So the perimeter equals 16.216 units. Okay, now let's find the area. So this is the most work, obviously, perimeter, because we got our distance formula. But area is not too bad if you know what you're doing. Because remember, we want to do area equals 1/2 base times height. Okay, remember the base we want to line up with the grid. We want to either be going left and right or up and down. So it makes sense to make this my base. And now I need to measure the height at a 90-degree angle from the base. So if I go here and I go 90 degrees straight down to the base, I want to start at the top of the triangle and go down to the base. I end up with my height there. Okay, so my base looks like 5. My height also looks like 5. So my area would be 1/2. Base is 5. Height is 5. So that would be 2.5 times 5, which I believe is 12.5 units squared. Okay, let me just double check that. All right, we're good. Okay, all right, so I'm just gonna leave it here, and that's about all it is. We've done distance formula, we've measured segments. It's just kind of putting it all together. Obviously, some of them have a lot of steps to it, so especially, well, I should say every single one of these show your work. There is not one of these problems where there's not work to be shown, okay? So show your work, good luck on your assignment, and yeah, that's it. Have a great day.